everyone. Welcome to episode number 587 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. This week, Bob Beachler from Untether AI explore Untether AI's unique approach to AI inference acceleration. We also chat about their recent collaboration with ARM and the benefits that this collaboration brings to autonomous vehicle applications, and where Bob sees the evolution of AI-driven devices headed in the future. Also, this week, I investigate how new research from the University of Michigan could help us decode dog barks with the help of AI. Before we get barking, please welcome Bob Beachler from Untether AI. Hi, Bob. Thank you so much for joining me.
Great to be here.
Excellent. Okay, so Bob, let's talk about Untether AI. How did it come about, and how would you define what the company creates?
Well, it came about, there were three founders in the Toronto area. And Toronto, as you might know, is a hotbed of artificial intelligence. So around 2018, these three folks got together and were looking at what was going to happen with AI. And they said, there's got to be a better way to do AI compute workloads than what we're using today with CPUs and GPUs. So these three folks founded the company on the premise that there's a way to run AI inference faster, cooler, and more cost effectively. And they developed a technology that they call at-memory compute, which we can go into at some depth if you'd like. But in its essence, what it is that it moves the compute for the AI workloads to where the data is, primarily in your SRAM cells on the chip. So we place processing elements directly attached to the memory. And unlike, say, a von Neumann type of architecture where you have external DRAM and then on-chip caches, and then you send the data to the actual processing elements in your pipeline, in that architecture, 90% of your energy is actually just used in data movement, and only 10% is used in compute. With AI workloads, they have huge amounts of compute requirements. And so you can imagine wasting 90% of this energy before you even get to the compute. So that's what the founders did, is they came up with a way, let's move the compute to where the data is. So it has shorter distance to travel, so it's more energy efficient. And therefore you can have more compute density for a given power on.
That makes sense. Now, Bob, let's talk about Untether's chip architecture. How would you describe your architecture versus traditional approaches?
So the first thing is that we're not a von Neumann architecture, right? We are cacheless or cache-free. It's much more of a spatial architecture, analogous to FPGAs, but a much higher level of granularity. So in the case of FPGAs, where you have lookup tables and some multiply accumulate functionality to do the actual types of logic that you want to do. In our case, we use customized RISC-V processors. On one chip, we'll have over 1,400 RISC-V processors, all running custom instructions specific to our processing element workloads. And in that way, we're quite different from what you've seen in a traditional compute approach. And that's what provides the benefit for artificial intelligence acceleration.
So what about some real-world applications? What kind of cool stuff can Untether AI technology do?
You know, AI is going to be everywhere, if it's not already, from the data center to the endpoint. And our architecture is scalable, and so that we can use one chip or many chips. And so we go from, what we call a heavy edge application, where people will buy our chip and use it, for example, for identifying radar signatures in certain types of aerospace applications, to do high-speed machine vision to find defects in assembly lines, where we're running a complex neural network looking for anomalies. In the case of, for example, in call centers, you'll have AI that'll run doing speech to text, and then do sentiment analysis on that text so that people can be aware if there's something going on in a call center that all of a sudden we have a lot of irate customers. You can use AI to give you an early warning and to escalate the issues. Those are just a few of the applications. Another one I think we'll touch on is in autonomous vehicles, where they're voracious consumers of AI and need a tremendous amount of AI compute.
So let's talk about your approach to AI inference acceleration. How does it differ from existing solutions in the market? And what kind of advantages does it offer in terms of performance, efficiency, and scalability?
Yeah, so because we're a non von Neumann architecture and we're designed from the ground up to do inference acceleration, what that does is that gives us a tremendous advantage in throughput, where in the case of vision applications, we'll be able to do more frames per second. In the case of language applications, more queries per second. But more importantly is the energy efficiency that we bring. So we use a metric called frames per second per watt, meaning how much energy does it take you to process this neural network to get you to the number of frames per second? Because that goes to your total cost of ownership. Or in the case, for example, with autonomous vehicles, energy would be very important because it may limit the distance an all-electric vehicle can travel. If you're sucking up a lot of your energy to do your AI compute, you're going to degrade the number of miles that the vehicle can go between charges. So energy efficiency is a key thing for AI applications. You probably heard about people are concerned about data centers consuming all the energy on the planet. And that's certainly a real possibility. And that's one of the things that we try to address with our technology.
So I saw that Untether recently announced a collaboration with ARM. Can you talk about that collaboration and specifically the benefits that it brings to autonomous vehicle applications?
Yeah, it's really great, the partnership we have with ARM. So in the case of autonomous vehicles, the level of autonomy that you can get to is directly associated with the amount of AI compute that you can handle. So in our case, we're an accelerator, right? We always sit next to some CPU that feeds us our data. We run the neural networks, and then we provide the results back to the host CPU. So it's a natural partnership with ARM because we are about energy efficiency. ARM's claim to fame, of course, in their CPUs is energy efficiency compared to an x86. So it was really a nice match between the two of us where ARM provides the CPU technology to autonomous vehicle or automotive vendors. We provide the AI acceleration, and we seamlessly hook up to the ARM CPU, and we can then run and accelerate the AI workloads. So again, it's all about the energy efficiency that the two companies bring to the issue of autonomous vehicles and AV compute.
Okay, so Bob, what role do you see Untether AI playing in the shaping of the future of AI driven devices?
So, we see a future where, AI is almost everywhere. People like to say that software ate hardware, and people are now saying AI is eating software. We see AI applications being, again, from the data center to the endpoint and anywhere in between. And our goal at Untether AI is to provide energy efficient AI acceleration, whether you're in the data center, whether you're at the heavy edge, whether you're in an autonomous vehicle, because our architecture is inherently scalable. We're spatial, analogous to an FPGA. In the FPGA world, you always had smaller FPGAs and really large FPGAs. We're very similar. We can make small devices, we can make very large devices. And so we do span from that data center class application to, autonomous vehicles and heavy edge applications. And, our goal is to be everywhere where AI inference is being deployed, where people need the throughput, the low latency, and the energy efficiency.
So, with the increasing demand for AI driven solutions, Bob, what strategy does Untether AI employ to stay ahead of the game?
What we do is a lot of research in terms of how do we make AI compute more efficient and to stay ahead of the game. So I'll just give you a couple examples that we do in our hardware software co-design. With our latest speed AI devices, we introduced a new data type called FP8. It's an 8-bit floating point data type. That was through our research. We found that we could use 8-bit floating point that would give us better performance and better accuracy than, say, an integer data type. And so we made sure to design our chip to be able to optimally process that data type. Unbeknownst to us, there was a parallel effort going on at NVIDIA. And NVIDIA was investigating 8-bit floating point data types more so for their training. We are doing it for inference. And it just turned out that one of our 8-bit floating point data types is identical to one that NVIDIA in parallel had developed. So those are the types of things you do to stay ahead. We look at hundreds of neural networks. Every customer we talk to seems they have their own custom neural network that they want to run. And so we're constantly looking at those and looking at what can we do on an architectural side to be able to run those neural networks faster, cooler, and cheaper.
All right. So, Bob, what major milestones or achievements have you guys reached since your inception? And what cool developments are you excited about in the future?
It's been a rocket ship. So I joined the company 4 years ago, right when the pandemic lockdown happened. And at that point, they were just close to taping out the first generation of device. They had raised about $27 million in funding. So since that time, we launched our first generation of product. That was the Run AI device. We raised another very large funding round, about $100 million in the summer of 2021. At Hot Tips in 22, we introduced our second generation Speed AI device. And that Speed AI device is now back in the lab, and we're bringing it up, and it'll be sampling this year. So in really just 5 years, we were able to put into practice this concept of at-memory compute, develop 2 generations of silicon, and on top of all that, we've also developed the software development kit that we call the Imagine SDK that allows people to easily lower their neural networks and get them running on our silicon.
Fantastic. Now, to end things off, Bob, what advice would you give to aspiring engineers and designers looking to innovate in the AI space based on your long years of experience?
You know, I was a little bit despondent, I think, in the early 2000s that there would never be new semiconductor startups. It seemed like that the innovation had passed and everything had really kind of coalesced into some major players. With the advent of AI, we're seeing a tremendous renaissance in startups, both on the silicon side and on the software side. So, my advice to the engineers, and this is kind of what I did as an old FPGA person, I saw AI as this is going to be the next new thing. And so I need to be a part of it. So having an inquisitive mind, self-educating, and putting yourself out there to say, okay, what is the next mega trend? What's the next really hot thing? As an engineer, you want to gravitate towards that because that's where the excitement's going to be. And now we see that there are over 50 different AI silicon startups and probably twice that many software AI startups.
I love it. All right, Bob, I forgot to mention I'm going to ask you a silly question to end the interview. So here we go. Okay, sorry for not warning you.
I'm ready.
Okay, so Bob, it is time for your off-the-cuff question now. If you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Oh, I'm a little biased because I'm co-owner of a restaurant in Saratoga, California called the Plumed Horse. And my favorite dish there is a cracked peppercorn souffle with a Dungeness crab and uni sauce that gets punched into the souffle, and it's to die for. That would be my number one meal.
Bob, that sounds amazing. What a great answer. Well, I think that's all I have time for today. Thank you so much for joining me.
Amelia, thanks for having me. It was great catching up with you.
So get this. The University of Michigan and Mexico's National Institute of Astrophysics, Optics, and Electronics Institute in Puebla recently released research that explores the possibility that AI and developing tools could be used to identify whether a dog's bark conveys playfulness or aggression. Director of UM's AI laboratory explains the motivation behind this research like this. By using speech processing models initially trained on human speech, our research opens up a new window into how we can leverage what we built so far in speech processing to start to understand the nuances of dog barks. There is so much we don't yet know about the animals that share this world with us. Advances in AI could be used to revolutionize our understanding of animal communication. And our findings suggest that we may not have to start from scratch. So, why did they not have to start from scratch? Well, as you can undoubtedly imagine, there isn't a lot of data available to develop AI models that analyze animal vocalizations because there aren't as many resources or opportunities to record that kind of data from animals compared with humans. The lead author of this study explains this obstacle like this. Animal vocalizations are logistically much harder to solicit and record. They must be passively recorded in the wild, or in the case of domestic pets, with the permission of owners. So, before this new research, there was a big lack of usable data. Techniques for analyzing dog vocalizations had been proven to be difficult to develop, and the ones that did exist were limited by a lack of training material. So, how did they overcome these obstacles? By repurposing an existing model that originally was designed to analyze human speech. So this approach allowed this team of researchers to tap into existing robust models that are the backbone of voice-enabled technologies today, including voice-to-text and language translation. The lead author of this study explains this element of their research like this. These models are able to learn and encode the incredibly complex patterns of human language and speech. We wanted to see if we could leverage this ability to discern and interpret dog barks. So first, they used a data set that included dog vocalizations recorded from 74 dogs of varying breeds, ages, and sexes in a variety of contexts, and a speech representation model called Wave2Vec2, which was originally trained on human speech data. And with a couple modifications, this team was able to generate representations of that acoustic data collected from the dogs and interpret these representations. And they found that Wave2Vec2 not only succeeded at 4 classification tasks, it also outperformed other models trained specifically on dog bark data, with an accuracy up to 70%. UM's AI laboratory director explains the ramifications of their findings like this. This is the first time that techniques optimized for human speech have been built upon to help with the decoding of animal communication. Our results show that the sounds and patterns derived from human speech can serve as a foundation for analyzing and understanding the acoustic patterns of other sounds, such as animal vocalizations. So, this team points out that using human speech models to analyze animal communication could have benefits for animal behaviorists and biologists. But it doesn't stop there. It could also improve how humans interpret and respond to the physical and emotional needs of dogs, thereby enhancing their care and preventing possibly dangerous situations. Super cool, right? So if you want any further information about Untether AI or this sparkingly cool research from the University of Michigan. I've included a couple links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into X, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we are now also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Also, make sure that you subscribe to this here podcast on Spotify, Podbean, Apple Podcasts, or just about any other podcasting platform to listen to some exciting upcoming episodes. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of June 21st, 2024, I'm Amelia Dalton, and you've been fried.